All right, today we're going to be practicing waiting on you. Okay, refocus, please. You should have out something to write with and a highlighter. Part of your ecology teaks say that you have to understand that just like energy, matter cycles through an ecosystem. If you don't have a highlighter, you can use a yellow, pink, or orange marker out of your supply buckets. When I copied this, I made an error. You should have this side facing up. If you look, it says page 2 of 2. It was copied backwards. So what I want you to do is rip it apart and turn it here where it says page 1 of 2. We're going to practice our marking the text strategies. So we are going to number our paragraphs. We are going to circle vocab, are we ready? And either underline or highlight. I put info. That just means important information. We're also going today we're going to do something called writing in the margins. And that's personal. That's something that's going to tie back to something in your life, something you already knew, or something you're interested in. So I'm going to randomly call on people in the class to read out a paragraph. As that person reads, I'm going to be modeling, marking the text for you. Does your text have to match my text? No, it's personal, right? Mine is just an example of what it could look like. Let me start with Cameron. We're on paragraph 1. Read the first paragraph for us.
There are many sources of energy in our world. Most energy comes to us either directly or indirectly from the sun. Solar energy is a regular source of most of the energy on Earth. Earth from the sun heats Earth's surface and the air above it. Sometimes it causes wind. Water evaporates by the sun form cloud, and rain to give us flowing rivers and streams. Both wind and flowing water are sources of energy.
So I know that we are starting to use wind energy I wrote solar. It's actually not solar. But we do use solar panels for electricity. We also use those big wind turbines for energy. And a lot of times there's something called hydroelectric dams. That's where they turn the power of water at a dam into electricity. So I know that everything in this paragraph is true. I have heard of that in one way, shape, or form at other times. Second paragraph, which is this section here. Jason, read for me. Algae. That's right. So I know that either last year in 8th grade or last year in IPC, depending on what grade you're in now, you talked about chemical reactions. And I know that you talked about the reactants, the yield, and the products. RYP. Does that sound familiar? RYP. Reactants, yield, products. Your reactants are always on the left side. They're what you start with. Your products are always on the right side. They're what you end with. Photosynthesis and respiration are two things we are going to learn a lot about this year in biology. So, you can put a question mark, photosynthesis and respiration, meaning we're going to learn more about that later. Third paragraph. I want to say Alicia, but I'm not sure that's right. By Sylvia. Remind me of your name. Kirsten. I'm sorry, Kirsten. I don't know where I got Alicia from. Kirsten, can you read the third paragraph for us? All right. So when we eat, we've been talking about food chains and food webs. When we eat plants or we eat other animals, we are ingesting their energy in the form of molecules. What make up molecules? Molecules would be like H2O. H2O is water. What makes up water? Atoms. And atoms are specific to each element. All right? So it goes molecules. Below that are elements. Elements are made of atoms. And the parts of an atom are? What are the parts of an atom? I know you learned it in 8th grade. One stands with a P and it's positive. Protons. Electrons and neutrons. Very good. Paragraph 4. Raylan, read for us.
You need energy to move and to think. You also need energy to
Synthesize.
little molecules. Some of the molecules are used for growth and repair, while others are used to fight off disease. Every movement of every day, your body needs energy. These energies come from food molecules such as glucose.
Glucose, yes.
Glucose. Your food can actually be thought of as food for your body. When you cells of your body, oxygen from the atmosphere is used to break down food molecules and release the energy stored in them. This process has separation as food such as sugar, glucose is broken down. Carbon dioxide, water, and energy are released.
All right, because I'm your teacher and I've taught biology a couple of times, I know that when I talk about photosynthesis and respiration, that it's a cycle. I know that the things that photosynthesis makes are used by respiration, and the things that respiration makes are then used by photosynthesis. These two processes feed into each other. I also know from 7th grade, when you studied photosynthesis with either Mr. Menifee or Mr. Urmston, I know that the formula for glucose is C6H12O6. That's its molecular formula. Paragraph 5, read for me, Jose.
Plants, like animals, also respire. When it is dark, plants use oxygen and release carbon dioxide as they break down sugar for their energy needs. During the day, in sunlight, photosynthesis is going at a faster rate than respiration. So during the day, plants release more oxygen than carbon dioxide. Yet they are still respiring and releasing energy from sugar. Photosynthesis, however, is producing more oxygen than plants require for respiration.
So where does our oxygen come from? Yeah, CO2 is turned into O2 by what process? Who do we depend on to make our oxygen? Plants. The sun too, right? Because without the sun, there would be no photosynthesis.
You're right, Kim.
So as we mentioned the other day, what happens to us without the plants?
Can't breathe.
We can't breathe and then we die. What happens to everything without the sun? Yeah, there's no energy coming into our biosphere. And the whole cycle will eventually putter out and everything will die. I'll give you a second to finish marking your paragraph 5. Say that again, babe.
Paragraph 3.
Yeah? Energy is ingested in the form of molecules. I apologize, there's not much room there. I should have written that somewhere else. Now we're on to the back of this. Dun, dun, dun. Andrew, we're on paragraph 6, which is the first paragraph on the back of the page. Will you read that for us, please, sir? Hang on, we've got too much chatter.
Food and wood are biomass. When biomass fuels are old, extremely old, and have become concentrated through natural events, they are called fossil fuels. Fossil fuels are found located in rock formations that are millions of years old. Coal was formed from the remains of trees and grasses that grew in vast swamps. 345 million years ago. When the plants died, they sank below the water. They became concentrated at the swamp bottom and layers under conditions, and preventing them from reaching and reacting with oxygen.
So part of this cycle of matter created oil. Oil creates gas. What do we use gas for? Cars. What else? Machines. How about heating your house? Yeah, some people do. Some people have gas stoves to cook their food. So, the concern is that we have been using so many, they're called fossil fuels, that maybe we eventually run out. If we run out and we don't have a backup plan, how do we operate our cars?
The sun's energy.
Through the sun's energy. That's one way, right?
They're making cars.
They are. They're making solar-powered cars, and they're making flex fuel cars, right?
What is flex fuel?
Flex fuel are alternative fuels that aren't made from oil. At least not natural oil as harvested from the earth. They can actually use oil from kitchen fryers and make gasoline for your car. Yes, Isis?
Can you put it down?
Yes, ma'am, I sure can. Paragraph 7. Read for me Austin Jones.
No problem.
Hey, guys, there's a lot of people in this room, and when our classmates read, some of them have lower voices than others, which means you need to be intentional about not rustling your papers or moving around or even whispering or throwing a Gatorade bottle in the air so that we can hear that classmate read. Fair? All right, go ahead, Austin. Yes, sir. All right. Last paragraph. Read for me, Amaya. Appropriate.
Appropriate that oxygen and carbon dioxide be maintained. Plants provide oxygen and sugar for ecosystem. Both plants and animals provide carbon dioxide and water to the ecosystem. The process of photosynthesis and
Respiration.
for one another. The movement of carbon through photosynthesis, respiration causes carbon cycle. The burning of fossil fuels was very important to break the carbon cycle.
Okay, so here we're going to draw a diagram to represent this cycle. For photosynthesis, I'm going to draw a tree. For respiration, I'm going to draw a person. We respire. Part of it is breathing in that oxygen, all right? So trees are going to give us O2. We are going to give trees CO2. Look right here in this molecule. CO2 is carbon dioxide, but what element is present? Oxygen and what else? Starts with a C, ends in arbon. Carbon. So this is a carbon atom. What is this cycle called? What was the title on this page? That's the gist of it, guys. Molecules are made of elements. Elements are made of atoms. This particular molecule is CO2. It has 1 atom of carbon, 2 atoms of oxygen. The carbon is moving back and forth between the person and the plant, cycling through the ecosystem. That's what we call the carbon cycle. Now, let me tell you, off here to the side, we're going to make us a little box. Doesn't have anything to do with the carbon cycle, so we're going to put a little dilly-dally beside it. Biomagnification. That's a big, fat, scary word. It's somewhere in, oh, it's right in front of Armani. B-I-O-M-A-G-N-I-F-I-C-A-T-I-O-N. NIF, IC, AT. Wait, I'm going to start over. Hang with me. BIO, MAG, NIF, IC, AT, ION. Biomagnification. Just like the good elements, the good molecules cycle through an ecosystem, so can poisons. So can toxins. Jason, that's enough. Toxins also cycle through ecosystems. Here's where it gets different. You know how you go up, Cameron? You know how you go up an energy pyramid? Is the energy the smallest or the biggest at the top? The energy. Smallest, right? Guys, it's the opposite for toxins. Toxins build up in an ecosystem as you go up the food chain or up the pyramid. Have you ever heard somebody say that there's too much mercury in the fish? If you're a fisherman, you may have heard that. That's because in that, specifically large fish, large game like tuna and marlin, shark, because those are your bigger predators. They're higher in that food chain. Toxins have built up over time. So toxins also cycle through ecosystem, but build up rather than decrease. So energy decreases up an ecosystem, or I should say up a food chain. Toxins do not. Toxins increase up a food chain. This document, if you remember from your rubric over me grading your binder on Friday, this is worth 10 points. Go ahead and put it in your binder behind your biology divider. Here is your assignment for the remainder of class. You have one other document called the nitrogen cycle. It is a two-side, or actually this back, how do we relate? We've already done that. No, ma'am. What I want you to do for the remainder of class, this is independent, quiet work. We're not going to be up moving or acting a fool. You are going to number your paragraphs. You are going to circle vocab. You are going to highlight claims. And you're going to write in the margins. Does everybody understand your assignment until it is time to go? Does anyone have any questions about your assignment until it is time to go?